notice, and this is a typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027 schedule of videos. These first three sections, 1, 2, and 3, number theory and computation, consumer arithmetic, and sets, all three with 51 videos have already been published on YouTube in their entirety. Section 4, 17 videos, they have all been completed. 5 of those have been published in their entirety on YouTube. Section 5, statistics, we are now at video 9 of 17, and I am behind schedule. Section 6, algebra, then after that, section 7, relations, functions, and graph, section 8, geometry and trigonometry, and finally, section 9, vectors and matrices. As I said, I am far behind schedule. Hence, this disclaimer, it was just a projection, and now it does not seem as if though it will be fulfilled. Reminder from section 1, number theory and computation. All 33 videos from that section, as I just pointed out, have been made available on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. 33 videos. So please make sure you look at those 33 videos and know them well. Another reminder that you need to know the times tables 2 to 12, especially since calculators are not allowed in paper 1. From section 2, all 12 of these videos have been made available on YouTube in their entirety, consumer arithmetic. And then from section 3 on sets, all 6 of those videos have been made available on YouTube in their entirety. As for section 4, measurement, with 17 videos, these have been published on YouTube in their entirety, these in yellow, and then these others are only published partially. Right now, we are at statistics, section 5. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get more practice questions. CSEC recommends the following, as shown on the right here. Please pay close attention to these last 2 down here, since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math examination. This is a picture of volume 1, Mathematics, a Complete Course with CSEC questions by Raymond Tulsi. And this is a picture of volume 2. Disclaimer, I get no financial or other benefits from the sale of these books. Also, very recently, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, and that is from paper 2, the structured questions. You can navigate by topics or years, where all questions for the past several years have been worked out. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained to you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be good answers to such questions. This is the URL of that website, and I will show you the home page for that website in the next slide, which is this page that you see here. Note you would have to register first, and then subsequently you would sign in. Here is the URL again up here. I will include this URL in the description below so that you can just click on it and be redirected to this website. Another reminder that for the math examination at the CSEC level, you will be provided with a formula sheet that looks like this. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the syllabus, it is included in the syllabus. This is the top part of that same formula sheet, and this is the below part of the formula sheet. So statistics, section 5, print screen. These are the first 5 objectives. We have completed those in 7 videos, as this objective here required 2 videos, and this next one here, 2 more videos. We have completed objective 6. We are now at objective 7, video 9, and this is page with all objectives from section 5, statistics, 14 objectives. I have divided those 14 objectives into 17 videos. 17 videos. We are at this point here where this red line is. Those 2 have already been published on YouTube in their entirety. These others are completed but only published partially. So as I said, we are now here, 5.7 part E, which is video 9. Once this video is completed, it will be published in its entirety. Please note that this section, which is section 5 on statistics, is of particular interest, as you will have to make use of many of these concepts in your SBAs, whether that SBA is physics or chemistry or biology or any other subject such as social studies or POB. You will have to perform something called analysis and interpretation for your SBA, which means that you would have to collect data, you would have to analyze the data, often by using a graph, most likely a line graph or other types of graphs, and then you'd have to interpret that graph, you would have to extract information from that graph. You will also have to do projections from that graph. So as I said, we are here, objective 7, determine the measures of dispersion, that is spread, for raw ungrouped data and for group data. And the explanation here is we need to know about range, interquartile range, semi-interquartile range, that's for raw ungrouped data, and also estimating these measures for group data. So we will split this objective into 2. Part A, measures of dispersion of raw ungrouped data, that is this video, video 9, and in the next video, video 10, we will deal with part B, measures of dispersion for group data. So recall, in the last 3 videos, we were dealing with measures of central tendency. So that was video 6 for raw data, video 7 for group data, and then in video 8, when it is most appropriate to use mean, median, and mode. So those were the 3 measures of central tendency that we looked at: mean, median, and mode. But those are not enough to correctly understand or appreciate a piece of statistical information. We also need to know about the measures of dispersion. Now, measures of central tendency tell us how closely these values are, whereas measures of dispersion tells us how far they are. And for this video, video 9, we will be looking at measures of dispersion for raw ungrouped data, and video 10, those same things for group data. And then for video 11, we will be looking at standard deviation, not in detail, but what it means and how to use it. So let us say that we have this test 1 here in math. We saw this before. That is not sorted. If we sort it, we have this. So the marks are sorted. The marks are sorted in descending order. We have done some statistical analysis on that, and we know the mean, the median, and the mode. The mean, this, the median, which is a middle value, which is that. We know the mode, which is the most common value. We have here 60. We know those things. Those are measures of central tendency. Now we can also derive the minimum value there, which is 48. The maximum value there, which is the highest, which would be 72 up here. We can also find the range, which is the difference from the minimum to maximum. So it's the difference between 72 and 48. And then we can also calculate the standard deviation. Right now, you don't need to know that. And even then, we wouldn't need to calculate it, just what it is and how to use it. So if you were given just the measures of central tendency, you would have a distorted version of what this means. However, if you look at the measures of dispersion, we have a completely different picture of what happens. So given only mean, median, and mode, that is not enough. We also need measures of dispersion to better understand the situation. So now let's consider test 2 scores. That was test 1. Let's consider test 2 scores. We will expand this piece below here. Now we could see both these tests. Test 1 on the left here, test 2 on the right here. If you look at the measures of central tendency, they are very, very similar. The mean here and the mean there, the median and mode here, and the median and mode here. As I said, if that is all that you had, you may not have the right idea of what is happening. But when we look at measures of dispersion, we find out that the range is 24, whereas here the range is 79. So from the lowest to the highest here is a difference of 24, and over here from the lowest to the highest is a distance of 79. And later on we'll find out that this standard deviation here, which is just about 6, and this one here, which is 23, what that means. So when we look at the measures of dispersion, we now have a clearer idea of what is happening with the data sets that we have. So we can see this more clearly on one of the many types of graphs and charts that we learned about. Here you have a column graph or chart for test 1. This red line here represents the mean, which is just about 859. That's the mean. And then this blue line here represents both the median and the mode. Notice they are very close to each other. If we look at test 2, you will notice, if we consider measures of central tendency, that the mean is basically the same thing. So that's the mean, and the mode and median are here. So when you look at this, it looks like the same thing. except that you can clearly see that this one here is from 98 down to 19. So you have a range of 79. So even though the mean, median, and mode may look similar in both test 1 and test 2, the scores are far from similar. Now we can also see this a little clearer if you put both of those math tests on one graph. This time we are using a line graph. This blue one here is test 1, and this brown one here is test 2. So that's test 1 up there, test 2 down here. Mean for both of them are basically the same, and the median and mode for both of them. However, if we look at the range for test 1, this is the lower range. That's the lowest that this blue line goes to. And this is the upper value, as the upper part of the range. So the range is just from that red line there to this one down here, which is a difference of 24. So that was the range for test 1. If you look at test 2, the lowest mark is way down here, which is 19, and the highest mark is up here, which is 98. So now the range is from that blue line up there right down to this blue line down here. That is the range for test 2, which is 79. So the point I am making is you need both measures of central tendency and measures of dispersion to make a meaningful judgment on the data that you are given. Yes, given only mean, median, and mode, that is not enough. We also need measures of dispersion to better understand the situation. So we continue here, objective 7. Determine the measures of dispersion or spread for raw ungrouped data and for group data. We'll split it in 2 videos. Part A, measures of dispersion for raw ungrouped data, and that would be range, interquartile range, and semi-interquartile range. That's video 9. And then the next part, video 10, part B, those same things for grouped data. And once we finish with that, we will go to objective 8, which would be video 11, when we will return to standard deviation and what it means. So let's get back to this. Your syllabus, CXC Mathematics, page 65, defines range, and this is a print screen from your syllabus. The range of a set of numbers is the difference between the largest value in the set and the smallest value in the set. Let me make that bigger so you could see it. The range of a set of numbers is the difference between the largest value in the set and the smallest value in the set. Note that range is a single number, not many numbers. So let's go back to math test 1. We said that the minimum mark was 48. The maximum mark was 72. Therefore, the range will be the difference between those two, and that is 24. That was for test 1 that we were looking at. For test 2, we could follow the same procedure. Minimum mark was 19, maximum 98. The range, therefore, will be 98 minus 19, which would give us 79. So understanding the concept of range is simple. You just subtract the lowest mark or value from the highest one, and you get the range. If you have a small range, it means that the numbers are bunched up together. If you have a large range, then they are spread out further apart. If you find this video useful and interesting, please like and share. That is to say, like and share. you may also consider subscribing to this channel. So we have a definition for range, but we don't have any definition for interquartile range or semi-interquartile range, though the definitions are not very complex and not that difficult to understand. But for some reason, CSIC did not include them in the syllabus. But we'll get the definition and learn how to use them as we go along. Firstly, we need to deal with interquartile range, and once we find that, the semi-interquartile range is extremely simple to form. It's a matter of dividing by 2. As the name suggests, though, interquartile range is the range between 2 quartiles, interquartile in between. Now, so we will firstly have to identify what the quartiles are and then decide the range between 2 particular quartiles. We will revisit test 1. So by definition, a quartile is one of 3 values that divides an ascending ordered set of data into 4 equal parts. Well, it could be descending order too, but it must be ordered from lowest to highest or highest to lowest. So here is that test 1 again that we looked at before. It is ordered. You could say descending if you start from the top here, or you could say ascending if you start from below here, going up, but it must be ordered. Now, first, the median or the middle of the whole set. Now, this is called the second quartile, which is Q2, and it is a value below which 1/2 of the data lies. So since we have 25 values, half of those will take us exactly to 13, and that is 60, which means that Q2 is the median, and it is also 60. It has a value of 60. Secondly, we find a median of the below half, and we are not going to include Q2 from our counting. So we are going to start from this 12 here and go down to that 1. So those 12 values, we need to find the median of that. Since it's an even number, it would be between here, between those 2. That would be Q1. We will add those 2 numbers and divide by 2. In this case, the 2 numbers are 55. So Q1 is 55. That's the first quartile. And we will do the same thing above here for the third quartile. Remember, we will exclude Q2 because it's a single value. So we are going from 14 up here to 25. That would be 12 values. Exactly 6 above and 6 below will take us between here. So that will be Q3. Since there are 2 values there, we add them, divide by 2, and we get 60.5. So far, we can find all the quartiles. 1, 2, 3. We have divided into 4 quartiles. You have the first one down here, second one there, third one there, and the fourth one up here. But generally, we don't deal with that fourth one. So we can find these 3 quartiles. The interquartile range is simply the difference between the upper quartile and the lower quartile. That's what it is. Therefore, the interquartile range is Q3 minus Q1. We know that Q3 is 60.5. We know that Q1 is 55. We subtract those 2 and we get 5.5. And that is the interquartile range for this set of data that we have here. So previously we calculated the mean, median, and mode. Now we have the range and we have the interquartile range. This standard deviation, as I said, we will leave for video 11. you can think of the interquartile range as the range of the middle half of the raw data. So we're going from 1/4 here, right up there to 3/4 there. This part here, here to there, is the middle half of the values. Let's go back to test 2 as well and do the same thing. So we will divide this. We will find, first of all, where the middle value is. In this case, since it's 25 values, we'll just pick the 13th one. And so Q2, which is really the median, is 60. Again, from 12 come down here, we'll find a median of that. So that would now give us the first quartile, which is here, between the 39 and the 40. We add those two, and we get 39.5 as the first quartile. And we do the same thing for the third quartile. Third quartile, since we have 12 values here, we take the two middle ones, divide by 2, and we get 78. So the third quartile is 78, meaning 3/4 of the value fall below 78. So the interquartile range is the difference between the upper quartile and the lower quartile. That is, say, the difference between Q3 and Q1. And in this case, Q3 is 78. We will subtract from that Q1, which is 39.5, and we get 38.5. That is the interquartile range for the second test. So we had mean, median, and mode. Now we are looking at measures of dispersion or spread, the range, the interquartile range, and as I said later on, we will look at standard deviation. Interquartile range is the range of the middle half of the raw data set. You are going from quarter here to 3/4 there. So that blue bracket there shows the middle half of the data set. Now let's consider test 1 and test 2 together. Now we're using the same students and arranging them in the same order. This doesn't actually happen in real life. If students did test 1 and got these marks in test 2, they will not be ordered the same way. You will have a lot of variation. However, for the sake of this math class, we will just change up some of these numbers. And so we have the same order of students. So we have the quartiles, as in second quartile, which is the median, which is 60 in both cases. Then you have the first quartile, and then you have the third quartile. Now this differs. So if we look at a summary for test 1 and then test 2, you will notice that the measures of central tendency are basically the same. However, the measures of dispersion are so much different. Here the range is 24, and here it's 79. And test 1, the interquartile range is 5.5, which means the marks are not spread out very far from one another. Whereas down here, it is 38.5. So the marks are spread out quite a lot. So again, as I said, the interquartile range is the range of the middle half of the data set. Now, let's consider test 3. And this time, Edwards missed it. So the student who got the highest was not there. So now we have 24 students. Firstly, we'll find the median, which is Q2, the second quartile. But since we have 24 students, we don't have a particular number. it is between the 12 and the 13. In this case, those two numbers are the same, so the median is easy to find. You add the two numbers, divide by 2, and you still get 60. Secondly, we will find the first quartile, and we will have to begin at that 12 and come down, because that 12 is not included in Q2. So if you come down, we will be here, 6 that way and 6 this way. So again, we have these two values here. We find the median of those, and we get 39.5. That's Q1. Thirdly, we will find Q3. We follow the same procedure. From 13 here, going up to 24, we have 12 values. So obviously, two of them will be in the middle, these two here. We will find the median of that, add those two, divide by 2, and you get 76. So now we have all the quartiles. The interquartile range is a difference between the upper and the lower quartiles, that is, between Q3 and the Q1. So let's subtract Q1 from Q3, which is 39.5, that, from 76, which is this, and we get 36.5. So 36.5 is the interquartile range. Again, the interquartile range is the range of the middle half of the raw data. The middle half, from quarterway here, going up to 3/4 there, the middle half. So if we look at that from Microsoft Excel, we have mean, median, and mode. That's measures of central tendency. And then we have range. We also have interquartile range and standard deviation. Those are measures of dispersion, and you need both of those to properly understand. And that should suffice for range and interquartile range. We have one more concept for this video, and that is the semi-interquartile range. And this is extremely simple once you could find the interquartile range. So now for semi-interquartile range, as the name suggests, semi means half. Keep in mind that we can find interquartile range, which is Q3 minus Q1. Then the semi-interquartile range is simply 1/2 of the interquartile range. So it's Q3 minus Q1 divided by 2. But remember, you have to find Q1 and Q3 first. So let's revisit those 3 examples we already did with the objective of calculating the semi-interquartile range this time. So as I said, the semi-interquartile range is half of the interquartile range. So this was S1. We had the interquartile range as 5.5. And so the semi-interquartile range would be half of that, which is 2.75. Next one, test 2. Again, we had the interquartile range as 38.5. So the semi-interquartile range would be half of that, which is 19.25. And then test 3, we had the interquartile range as 38. So the semi-interquartile range would be half of that, which is 19. So semi-interquartile range is not very difficult to find. So let's review now what we have been learning. We will look at one last example here to review measures of central tendency. That would be mean, median, and mode, as well as measures of dispersion, and we will be looking at range, interquartile range, and semi-interquartile range. Later on in video 11, we will look at standard deviation, which is another type of measure of dispersion. So this time we are dealing with those students, 15 of them, and their weight. Let's look at measures of central tendency first. First, the mean. So you would add up all those weight and divide by the number of weight. So x bar, which means the mean, is the sum of all the x's. This is sigma x, which means sum of x divided by n, which is the number of x's. And so we divide 919 divided by 15, and we get 61.3. That is a mean. That is a measure of central tendency. Secondly, we look at median, and median is a middle value. And if there are two such middle numbers, we will find the mean of those two numbers to get the median. In this case, since we have 15, an odd number, 8 is fairly easy to find, so it is 62. So the median is 62. And then we look at mode, which is a value that appears most often. You could have more than one mode, or you could have no mode at all. In this case, we do have 53 appearing twice here. And so the mode is 53. So measures of central tendency, mean, median, and mode. They tell us how well these numbers are grouped together. Central tendency. But as I said, we need more than that. We still need to find range, interquartile range, and semi-interquartile range. And as I said, in video 11, we will look at standard deviation. So measures of dispersion, range, and that is the difference between the highest and lowest values. In this case, it would be 81 minus 39, and so we get 42. So these students, the range of their weight is 42 kilograms. Then we looked at interquartile range. To do that, we have to find the median, which is the second quartile, and then we find the median of above that and below that. So we will exclude this 8 here. And what do we have below? We have 1, 2, 3, 4, 5, 6, 7. So it's easy to find the median here. It's that, 48. And above, the similar thing, 74. So we have found the quartiles. Now the interquartile range would be the difference between Q3 and Q1. It would be 74 minus 48, and we get 26. That's the interquartile range. And once you have found that, the semi-interquartile range is 1/2 of the interquartile range. So we had those before. We got 26 as the interquartile range. Semi-interquartile range is 1/2 of the interquartile range. So we divide the interquartile range by 2, and we get 13. So now we have the range, we have the interquartile range, and the semi-interquartile range, measures of dispersion. Now, I entered the data on an online calculator, and that's the URL. And this is the answer I got. So these up here are the weights or the data points. And then I hit calculate. It gives us that the first quartile is 48, which is what we got over here. The second quartile is 62, which is what we got here. The third quartile is 74, which is what we got here. The interquartile range, which is the difference between the first and the third, is 26, which is what we got over here. 26. The median is 62. Well, that's a measure of central tendency. The minimum is 39, which is here. Maximum is 81, which is up here. Therefore, the range would be the difference between that, which is 42, which is what we had here. This calculator does not allow me to calculate for the semi-interquartile range. So objective 5.7 part A, determine measures of dispersion for raw ungrouped data. That's what we just did in this video. And then for the next video, we will do that same thing for grouped data. And that brings us to the end of video 9 based on objective 7 part A in section 5.